Welcome back. This is the second video for lesson 5.3. If you need the extra help, you can work through these last two problems. Try them on your own and check your answers with me if you'd like. So it says, according to a Gallup poll, 60% of American adults prefer saving over spending. X is going to be the number of Americans out of a random sample of 50 who prefer saving over spending. What is the probability distribution for X? So X is approximately binomial where my sample size is 50 and my likelihood of success is 0.6. So either try working this in Alex or Desmos. Desmos has the answer saved for you. So if you want to check that out, you can do so. Okay, the probability that 25 adults in the sample prefer saving over spending. So that's a probability of X equal to 25. And that comes out to be 0.0405. And Alex, that would be 50 choosing 25.6 to the 25.4 to the 25. 2 says the probability that at most 20. So the probability that X is less than or equal to 20 because we're including 20. That comes out to be 0.0034. And 3 says the probability that more than 30 adults. So the probability of X being greater than 30. So that means in Desmos, you're going to use the right and you're going to be greater than or equal to 31 because you're not including 30. So that would be 0.4465. We're going to check your answers there. The mean of this binomial is mu is equal to n times p, or 50 times 0.6, or we would expect 30 people to prefer spending over saving over spending out of the 50 with a standard deviation of 3.46 people, adults, right? And it says explain the mean and standard deviation. So when we have the binomial, we always say out of whatever our sample size is because it's changing. And the mean is directly dependent on the sample size. So we have to say out of the sample size, which is out of 50 adults, we would expect 30 of them, give or take 3.5. So give or take is where we're describing the standard deviation. So we would expect 30 of them, give or take 3.5, to prefer saving to spending. Last example 8 or less than 5.3. Says the lifetime risk of developing pancreatic cancer is about 1 in 78 or 1.28%. Suppose we randomly sample 200 people. Let X be the number of people who will develop pancreatic cancer. So our distribution is approximately binomial. 200 is n, and probably, unfortunately, success is if you have cancer, even though that's really not a success. As a decimal, it's 0.0128. Really be careful on that. So using the formulas, calculate the mean and standard deviation. So the mean is 200 times 0.0128 for approximately 2.56 people. And the standard deviation is 1.59. Use your calculator to find the probability that at most 8 people develop pancreatic cancer. So the probability that at most means we're including 8. And if you use Desmos, that's 0.9988. Or if you use Alex, they should come up with the same answer there. And D says, is it more likely that 5 or 6 people will develop pancreatic cancer? Justify your answer numerically. So they're probably that 5 develop it is 0.0707. And the probability that 6 develop it is 0.0298. So it's more likely that 5 people develop it than 6 because it's not really likely at all. So having 5 people develop it is not unusual because it's still bigger than 5%. It's 7%. Having 6 or more develop it is only about 3%. So that is considered unusual. And catch me back for chapter 6. Have a blessed day.